All right, let's get started. So first one, quick announcement. Again, reminder about that optional anonymous survey. So yes, it's optional, but yes, I'm going to encourage you to take it because feedback is always appreciated, positive or negative. So far, we've got 3 answers to that survey. And out of the 3 answers contain something that is useful, okay? So especially technical specification about the app that are not really up to standard. So if you catch stuff like that, yeah, point it out to me and we'll add it to the to-do list, definitely. So far I got good stuff, right? It's just that I want to get a more wider sense of how everybody feels about this, okay? All right, what else? So we are still in module 8. I removed a chunk from the initially planned slides for today because really we have covered informally a lot of that stuff actually, okay? So yes, last time was heavy in terminology. I would prefer to not have like multiple sessions one after the other that are heavy in terminology because at the end of the day, it's just vocabulary and you're going to pick that up in the reading assignment. That's what the reading assignment is there for, okay? So I try to refocus this lecture, change it a little bit from last time so that we go directly to the part that is actually, well, I think more interesting, all right? So we are going to introduce a concept, the concept of the call stack, or also known as the program's execution stack. So first thing, what is a stack? A stack is a data structure, okay? A stack is also a pile of dish. So why do we have a data structure that's called after the name stack? Well, it's a data structure where every time you store a new element, you add it to the stack and you always add it like you would add a clean dish, to a stack of dishes from the top. If you add another element, you add it again on the top. So the idea of a stack is you always add one way and pile up the data elements that you store in the stack. And when you remove data from the stack, you cannot just pick whichever you want. You have to pick always the topmost element. So that's what hence the name, right? You put things, add it from the stack. When you want to pop things out of the stack, you take the top one, then you take the top one, then you take the top one. You can only ever take the top one and add on top of the topmost element. Okay? That's stack as a data structure. While we are not in data structure yet, so I'm not going to ask you to implement stacks or stuff like that, but we are going to encounter the concept of stack right here as we deal with method, because internally, inside the memory space of your program, there is a data structure that acts like a stack. And what it is meant to hold, it's meant to keep track of the methods that you call. So every time you call a method, I'm going to make a note. Let's call it that way for now. I'm going to make a note that you call this method. So here's my little post-it. Okay, I write down you are calling this method. You are passing these arguments. Okay, this is how the arguments are going to map to the parameters. Blah 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 blah. Put that on the stack. Now I'm executing the method that you call. Are we done? Are we done executing the method that you call? Okay, I'm going to remove that post-it from the stack, and I'm going to go back to whatever I was doing before that, okay? So that data structure helps us keep track of what method we call. More importantly, it is central to properly allocate memory for the variables inside method. When I started introducing method, I told you, watch out, every method is like its own little kingdom, right? They each have their local variable, their parameter. Any variable, any form of variable that's declared inside of a method cannot be seen from another method. We don't communicate like that. We isolate so that the code doesn't spill out bugs, and propagate bug even faster than it does. So how do we achieve this with that stack? So when I said I'm going to put like on that stack some information about the name of the method I just called and maybe the argument that I'm passing and stuff like that, there's more to that. Okay, there's more to that. We're going to see that in a second. But pretty much what I'm putting on the program's execution stack, every time I call a method, every time I'm about to enter a method, is what is called an activation record. I activate a method, I call it, I'm going to keep some records of what's happening. Records of what's happening means mostly this is where all of the local variable for that method, all of the parameters for that method are going to be allocated. So now we're getting a little bit more specific. Okay, when you take COP2515, you're going to get even more specific than that. But right now, what we're saying is that when you start a program, and it doesn't really matter if it's Java, if it's C, if it's whatever, okay? But when you start a program, your program has a sort of virtual view of memory, meaning that if you are like on a 32-bit architecture, the program, which is kind of like old-fashioned nowadays, but the program is going to think that it has access to 2 power 32 bytes of memory. Every single program you load on your operating system, no matter the operating system, or at least the mainstream operating systems, right? Each program thinks that it has a whole memory for itself. And then the operating system is there to juggle that masquerade. Okay, it's there to kind of say, well, yeah, maybe you think that you have the whole memory for yourself, and you think you have the whole memory for yourself, but you know what? I don't have the max amount of memory. Somebody loaded me with 16 gigs, and that's all I have. So first problem, right? And second problem, if both of you want to claim the whole 16 gigs, then I have issues, right? So we are starting to enter the realm here of the operating system internals, right? When you load a program, where your data is going to be stored, where your variable is going to be stored, all of this has been the object of a lot of work, a lot of research, pretty much, to make it work when you have like just 16 gigs of RAM on one machine and you have 50 processes. That's what we call a program that is executing in memory, a process. And we have 50 different processes running right now in the background on this Windows laptop, right? And each of them is think that potentially they can access all the memory. So that's an interesting little trick there. Back to this. So what does it mean that we have to start learning about how we manage memory when we run program? Well, let's take a look at this piece of code here. So we have a main method. So variable I, j. So I and j are local variable to the main method. Args is a parameter for the main method. K, local variable again to the main method. We initialize I, j to 5 and 2 respectively. We call the method max with I and j as argument, so 5 and 2. And whatever return value we get, we store inside of k, also local variable inside the main method. And then we display the maximum between I and j is k. Okay, so nothing complicated there, okay? We could have done that probably first day of class. So what's interesting is what happens when we call the method. So let's take a look at the method we are going to call. It has 2 parameters, n1 and 2. It has a local variable int result. And then we compare n1, 2, and 2. We set result to the largest one, largest one, and then we return result, okay? So now, let's run through this. The moment you start your application, okay, I told you from day one, the main method is where everything starts. So the moment the operating system loads your application in memory, it's going to look for that main method and start executing everything in there. That's what I told you, right? Well, there is one step before that. As I enter the main method, I'm going to do what I do every single time I enter a method, which is set it up. Set it up by adding an activation record for that method call in the program execution stack. So the way we're going to visualize the program execution stack, imagine a column here, okay? This is, I don't remember actually if we go, I think we go, I should have done the stack inverted. We go from a high memory address to low memory address. I have to double check that, I always forget. But anyway, this is a strip of memory, okay? And what we do is we go at the beginning of that strip, the zone marked as a program execution stack, and we say, I'm going to reserve this much memory. So now this memory is reserved. Nobody else can use it for other variable, etc. I have control of it. I'm going to use, it's my resource, right? And inside the main method, I find out that I have one parameter. So there's going to be more information than just the variables, okay? But that you can discover that in COP2515. Okay, I'm not going to go that much in detail, but there is a little bit of information about the call to the method, and then there's going to be some memory reserved to store whatever value is in args. And args, we have not used it. It's just a way to get argument for the command line. We don't have much use for it in this course, but it's there. Once all the parameters have been allocated, I'm going to make room for all the local variable. Here's I is going to contain 5. Here's J is going to contain 2. And here's K. So right now, I read just the declaration, int I equal 5, int J equal 2, int K, and I didn't process yet this call to the method max. All of that is part of the setup where every time you enter a method, okay? So you set up your activation record, also known as a stack frame, whichever term you prefer to remember is okay with me. We set up the stack frame, we book a chunk of memory, and then we start sizzling into that chunk of memory space for all of our local variable. So the local variables for a method call, they exist in the activation record for that method call. That's part of why we cannot see them, from another method or something like that. When another method is going to run, like max, I'm not going to be able to access this. Consider this the private memory space for that call to the main method. And all of this happens at the beginning. And then somewhere, so it's going to happen also when I call system.add.println, by the way. This is another call to a method. But let's look at this one because we have the code for this one. When I call max, what's happening? The same thing that happens every time I'm about to enter a method. When I call the method, I'm going to, the moment I enter the method, push on top of the program's execution stack another activation record. This is the activation record for this call to the max method. So please note that I'm not saying this is the activation record for the main, and this is the activation record for max. Because if I phrase it like that, and sometimes I do because I don't pay attention, but any programmer that phrases it like that would kind of imply that there is one activation record per method. And yes, in this class, it's going to be true. There's going to be one activation record per method, but that's not going to be always true. By the time you take program design, COP2512, we're going to go a little deeper. Okay, we're going to talk about recursion. So this is where the game is going to change. So for now, the only thing you have to worry about is the fact that I'm not telling you that there's going to always be one activation record on the stack for the method max. You may not see exactly how that will happen. I'll show you at the end of the session if you're curious. But for now, it's going to look like it's true, but it's not always true. So what do I put into that max activation record? Same story. Parameters. N1, and N1 is initialized to 5. So I carve some memory here to store N1, and I look at what was passed to me as argument here. It's an expression. The expression evaluates into the value of I, which is 5. So I put 5 inside N1. That arrow there, it just tells you where the 5 comes from. That doesn't mean that the two variables are somehow linked to one another, okay? Maybe this is something that's a little bit confusing in that diagram, so I want to warn you about this. What about N2? N2 has its own memory space, okay? And then what else? Well, once we are done dealing with all the parameters, we deal with the local variable. So I have one local variable here, int result. I carve some memory to store result in my activation record for this call to the method max. And right now, I don't have anything inside result. I didn't initialize it. So what's inside the memory here, and I think it's worth pointing out right now, it's unspecified. Okay, and you are going to see when I return from the method, you're going to see why this can be considered almost random. Okay, so that's why I told you always initialize your variable. You should always initialize your local variable. Put a value so that you know what's in there. Because right now, at this moment in time, I have no clue what's there. The value of result is completely unknown to me. Okay. And then I do if N1 greater than N2, then result equal N1, else result equal N2. So I'm going to execute that code, and I'm going to end up putting into result the value, in this case, the value 5. And then I'm ready to return result. So when I'm going to return from the method and return a value, I'm going to evaluate this expression. We already talked about that. It's going to be 5. So I'm going to return the value 5 to whoever called me. What do I do with all of this junk? I'm not going to keep it around. I'm not going to keep around a memory record that one day, 10 milliseconds after starting execution of my application, I call that method and this is what happened. Once the method is done executing, I don't need its activation record anymore, at least for that call to the method, right? If I call it again later, I'll create another activation record. So I return my result. The result value is assigned to k, so 5 is assigned to the variable k back in the main activation record. And then all of this is going to go bye-bye. That's why a stack. Stack it, unstack, pop, pop, disappears. So here's the thing. If you think, we wipe this activation record from memory, you're not going to be that wrong, okay? Conceptually, yes, we wipe it, we trash it, we don't use it anymore, it's gone, okay? Technically, it's not gone, meaning that everything that was written in memory here, all the values that were assigned to the bits from here to here, right? They are still there. Because there's no point for me to clean. Well, there could be a point in terms of computer security, but bottom line is that almost no runtime environment zeroes all those bits. Because what they say is, you know what? This is the top of my stack. I'm done with the method. Okay, this is the top of my stack now. So I keep track of what is the topmost record on my stack. And since I said that this one is the topmost, next time I want to add something to the stack, I'm going to add it here. Next time I want to pop something out of the stack, I would pop it from here, right? Because this is the top of my stack. So it doesn't matter that I zero those bits. Well, it kind of matters because let's make a little parenthesis here. I'm done calling max. Then I'm going to call system.app.println. So for 1 second, indulge me, and let's say that under the line int k equal max ij, and before the line system.app.println, blah, 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 between those two lines, I do something like int w equal max of I and k. Anything like that. Any reason for me to call again the method max. What would happen when I execute that second call to the method max? I enter the method max, another activation record is going to be piled up on here. It's going to look like very similar to what was there before because I'm calling again the method max. So there's going to be an activation record here, and it's going to contain the parameters, and it's going to contain the variable, local variable, let's see, result. So there's going to be N1, N2, and result in it. What happens when I allocate like that an activation record? Do I write something in the memory? No, I don't. All I'm saying is I'm doing bookkeeping, right? I'm saying this is a chunk of memory here, this table. Okay, that's mine. Nobody touches that anymore. Okay, that's it. But I take the chunk of memory with everything that's written already in it. What is written in it? Well, the value for N1, N2, and result from my previous call to the method. They're like ghost, watermarks in memory. They're still there. So that means that I'm going to have this activation record. Inside of it, I'm going to have those ghost values still sitting around. And remember what I told you about int result? I don't know what's in there. Actually, what's in there is what was in there during the last call to max. So you may think, well, okay, it's not too bad. It makes sense, right? So you call something, you get a value in result, you exit the method, you call again the same method. Well, if you don't do anything, your uninitialized variables, they're still going to contain whatever they contained the last time that method was run. Yeah, okay. Could be not too bad. But what if I do int k equal max ij, like easy on the slide? And then I do system.app.println, the maximum, blah, blah, blah. And only after that, I do my int, I don't remember what letter I use, like int w equals max of I and k, for example. What if I don't call back for a second time the max method right away? I finish calling it for the first time, but I call another method. Well, when I call system.app.println, what happens when you enter a method? Activation record gets pushed onto the stack. This activation record is going to contain space for all of the parameters of system.out.println, for all the local variables that system.out.println is using, and so on and so forth. If they are uninitialized local variable in the code for system.out.println, they are going to take the value of whatever bits are in their location right now. And those bits were set by, what happened with Max the last time I called it. But it has nothing to do anymore. It doesn't correlate anymore. I could be looking at a double, and the double is going to be half of its bit set by the bits that were used for result. Okay, so that's why we say that uninitialized variables are dangerous. And then when I'm done executing system.out.println, so let's say that it uses an activation record that is even bigger than the activation record for Max. And I did some stuff. I assigned values to local variable. I changed values for parameters, blah, blah, blah. Pretty much I rewrote the binary bits in that memory space. What happened when I return from system.out.println? Well, the top marker for the stack says I'm back here. But I didn't wipe that activation record. It's not zeroed. So if I call again Max, I enter again the method, push on top of the stack the activation record for that call to the Max method, and that variable that's undefined, well, it's going to take whatever bits were left there by system.out.println. So that's the problem with an initialized variable. Could we theoretically keep track of what's happening? Maybe, I don't know. Really never gave a thought to that, honestly. The idea is it's going to get out of control. Nobody keeps track of that kind of stuff, actually. So instead, what we have is we have a policy, which is if you don't initialize your variable, assume that it's a random value. So when I try to read that int result before to assign a value to it, I don't know what I'm going to get because the memory is not cleaned between activation, record, poppings. Okay? All right. So it's a little bit more technical view of what's happening when we call a method. So here's the deal with those little bit more technical views. That's actually what your focus should be. Okay. Again, like if you were a physics major, biology major, I would not even bother you with that. But you're going to be information technology, cybersecurity major. So you need to know how things are working under the hood to a certain extent. We're not going to rewrite an operating system together. Okay, this is something that we do in a computer science program, not an IT program or cybersecurity. But we are going to still try to get you enough information about what's happening under the hood so that you can make well-informed decisions. One thing I recommend that you do is take some of the program that we have been playing with and do that stack diagram. What I had on the right-hand side of my slide is called the stack diagram. So as you trace through the code, and you don't have to do the full trace table, but as you follow along the execution of the code, try to keep track of the stack diagram. Again, it's one of those things, if you don't want to do it, don't do it. And maybe some of you won't need to do it and you understood already what this is all about. So don't waste your time. I'm okay with that. The others, if you want to actually learn and understand that stuff, yes, you have to spend like half an hour maybe doing that kind of grunt work. And then it's going to help you really understand what's happening when you call methods. Let's take a quick look here to JGrass. I want to show you something about the debugger real quick. And that's going to allow you, if you are like too unmotivated to do actually the trace like that, it's going to allow you to still find a way to get the benefit of doing the trace. So let's say that I have a public static int max, int I, int j. I could do with any method, but since we have been talking about max, why not? And I'm going to say return I lesser than j. I return I, else, I return j. Otherwise, it's a min. Else I return I. Okay, that's another possible implementation of the max method. And then here I'm going to say int a equal 42, int b equal 99. So double declaration on one line, and then system out println max of a and b. Okay. So nothing new compared to what was in the slide here, compiling to make sure I didn't put any typo in there. If I run this, it's going to display, of course, 99 being the biggest number of the two. So what did I wanted to show you that's new? We have been using the debugger a little bit. Some of you have been using it quite regularly, so that's cool. I can put a breakpoint here at the beginning of my main, and I can say, run this with the debugger. So using that beetle icon at the top here, there we go. And here's my debugger panel. So until now, when we looked at the debugger panel, we have been looking really at this. Okay, this shows me, for example, that there is a parameter args here in my method main. Okay, and if I go up one step and I declare A and B, then under the header local variable, it shows now variable A, variable B, their content, etc. So we've used that pane to pretty much keep track of the value of variable as we were stepping through the program. Okay, awesome. Now, what happens if I call a method like this? So it's maybe a little confusing to some of you. I don't know, you tell me, because I did system.out.println and then max on the same line. So what happened is I call max first, max return its value, and then the value is passed to system.out.println, which I can now call. So there are two method call on the same line, okay? If that confuses you, I can rewrite this differently. But I'm stepping in. I want to see what's happening. So here's the debugger telling me that I'm now inside the method max, and this pane is showing me, parameter I, parameter J, okay, equal to 42.99, perfect. I don't have any local variable in that method, so the pane followed me inside that method and shows me what are the variable in there. Where do we store the variable and parameters of a method when we call it? In its activation record. So this pane actually is showing me a view of the activation record of whatever method I'm currently executing. And this other pane here, appropriately named call stack, which is another synonym for program's execution stack, it shows me what is on the program's execution stack. Yes. How do I get the call stack for showing? It should show by default. If it doesn't, hold on. Now you really don't have anything at all to do. It's when you start the debugger, okay, when you enter a method, it should show the call stack. If it doesn't, just stay like 5 minutes at the end of the class. I'll fumble around a little bit with your laptop. It's just a matter of unhiding it. So you'll notice that those things here have like errors, right, and stuff like that. It's possible yours was collapsed at some point. I don't know. But we'll look for it. We'll find it, okay? So don't worry if you don't see it right now as you're like following along. We will get it to show on your system as well, okay? Yeah? Yeah, you run the debug. So you run this button instead of doing the running man, right? This is that one to start your application. And then as soon as you get into a method, you are going to see that panel. Make sure also that you see the tabs here on the bottom left, browse, find, debug, workbench. Make sure that you are in debug. Okay, for some reason, again, you might be in a different state, but if you are in debug, then you're going to see those two panes. All right, so this is the content of my current activation record, the one of the method I'm running right now. And this is my call stack. So the call stack, again, it's like put at the bottom, put on top, put on top. So it's telling me that the bottom activation record corresponds to livecoding.main. So number one activation record is livecoding.main. My name file is livecoding. My file name, is livecoding. And it was an activation record for the method main. So that makes sense. The activation record for the method main is at the bottom. On top of it, now that I am executing a call to the method max, I have number two here, which is livecoding.max. This is the activation record for this call to the max method in the file livecoding. And this one is highlighted. And whichever is highlighted is displayed here in the bottom pane, which means that if I'm running here max, and I look at I and J, and it tells me I is 42, J is 99, and I'm like, I forgot, where is that coming from? I can actually click the activation record for the main, and the bottom pane is going to show me the content of the activation record for the main as it stands right when we initiated the call to max AB. So I can see that A is 42, B is 99. Okay, so that's why I passed 42 and 99 as parameters. So now I can click here and go back. As I click on the activation record, I don't move through time. I don't rewind execution or I don't go fast forward. I'm just looking at different memory area on the stack. Yes. Yeah. It's where all of your parameter and local variables are going to be allocated. So why do we make a big fuss about it? You know, what else can we allocate? You guys remember? Do we have another type of variable that I mentioned like very discreetly in passing without making a big fuss that it was not allocated at the same location in memory? Objects. Every time you do new something, okay, you create an object in memory. Objects are not created on the stack. They are created in a different zone of your program's memory space, which is called the heap. HEAP, and we're going to talk about that very soon, talk about it a lot in COP2512, okay? But right now, that suggests that there are at least two zones of memory in the what we call the process, that is a program in execution in memory, the process address space. There is a stack and there is a heap. All local variables go on the stack, all parameters go on the stack, all objects you create go on the heap. What is the incidence of this? What is the meaning of this? Well, the main thing with the stack is what I'm going to make happen right now. Let's say that I execute that line of code. When I'm done executing the code for the method max, guess what happens? The activation record disappears. So now I'm back to whoever called max. So I'm back here right after the call to max. I got a return value. Now I'm going to call println, right? But what happened is that I'm back into the memory space for the main method's activation record. Okay, so everything that's stored in the stack is kind of temporary. It's like I'm going to execute a method. The method says, okay, I need this and this and this. I need my workspace. Then I'm going to use my workspace, and then when I'm done, you can trash it. I don't need it anymore. You call again the method. I want a new workspace. Workspace meaning memory, variables and stuff like that. And then it's always like setup, destroy, setup, destroy. Every time you call a method, it's temporary. What happens if I want to create, for example, a graphic user interface element? And I'm going to call some method and come back from the method and right and left. But you know what? When I call my method setup, even though the setup method has finished executing, 5 minutes ago, it created something on the screen, and the code for that object on the screen, that pane or whatever, that scroll bar or whatever, it needs to be still in memory, ready to handle events and stuff like that. That's why I use a heap. That's why I use objects. Objects are persistent. You create them, and after the moment you create them, wherever you are, doesn't matter. Like you are inside a method, you are inside the main, it doesn't matter. You create the object, it starts existing in the heap. When you return from the method, the stack part, the activation record is white, but the stuff on the heap is still there. So the other methods that called your method, they can still access that thing for the entire lifetime of your application. So that's another one of those things that the first time you learn a programming language, you get exposed to those concepts. Maybe, they don't make super sense. By the time you go a little bit deeper in programming, you start seeing the value of understanding those things. So typically, by the time you reach data structure, that should be already like the latest where you realize that this is actually important. And then when you are like applying all of this, then you realize that, okay, all of those policies, all of those rules that have been taught and asked to follow kind of blindly, now I don't have to memorize them anymore. I can reconstruct them. What is the scope of a variable? Can I access a variable from one method to another? No, if you understand what's happening here, you can answer the question yourself, okay? When you go to a new programming language, you're going to immediately think, okay, so how is it working here? Are they global variables, like variables that never disappear? Yeah, for example, JavaScript has stuff like that going on, right? So now what you should be thinking maybe is, well, so those global variables, they have to be somewhere in the heap. They are allocated differently, right? So the more details you work through that like that, the first time you encounter those concepts, okay, the better prepared you are to learn faster your second, third, and fourth and fifth programming language, and so on and so forth. Then if I keep running this, of course, I reach the end of the main, in which case, there we go. My activation record is gone. That was the last one on the stack. The application is completed pretty much. All right. So now we are going to use that to clarify an expression that you are going to use yourselves and hear other people use a lot. It's related to the policy that we pass parameter with. Okay, so when I pass parameters to a method, I already told you pretty much what happens. You evaluate the argument. Okay, you get a value out of the expression that's used as an argument. Then you take that value and you write it down inside the memory for the corresponding parameter. Well, that is called passing parameters by value. Everybody agrees on that, okay? That method of doing things, of passing pretty much values to parameters is called passing parameters by value, okay? What does it mean? That we copy a value. So if I have a variable in the main, and actually let's take a look at a piece of code because that's exactly what we're going to do here. If I have a variable x in the main, right, and I call increment x, we did that experiment already a few lectures ago. If my method increment takes a parameter n and increment n, now you understand why x is never touched in the main, because x and n are totally different variables. So if we do the stack diagram, I enter the main method, I get an activation record for the main method pushed onto the stack. I need room inside of it for the arguments. I need room inside of it for the local variable x, initialized to 1. I display before x is 1, and then I call the method increment x. When I enter the method increment, then, well, first, before I enter the method increment, I evaluate the argument. X is just a variable, so it's an expression that's easy to evaluate. I look up the value of x, it's 1. And now I take that value, I keep it. I'm going to allocate my activation record for the method increment. And once the parameters are allocated in memory, then I'm going to copy that value into the new location in memory. So x and n have nothing to do with one another. That's super clear, okay? So now you see why they live in different activation records on the stack. And n is temporary, meaning that, yeah, I can do whatever I want on n, but as soon as I reach the end of the method increment, okay? So modifying n has not modified x, first thing, but that should be clear by now. And then when I reach the end of the method increment, there you go, n pretty much disappears. That's why it didn't work out when we tried to do that again a few lectures ago. So we kind of revisit with a little bit more detail now. And then when I'm going to return from this method, I'm back in the main. And then obviously when I'm done with the main, the activation record for the main is going to also disappear. So that's what passing parameter by value actually technically means. We copy a value that is inside a variable, maybe. We copy it inside a parameter. Or we evaluate an expression. We get a value out of evaluating that expression. And we copy the value, that value, into our parameter variable. So after that, they can live happy ever after. I already did that, I think, a few lectures ago. We did that together, actually, but I'm going to show you with the debugger what's happening just real quick. There's nothing like transcendental here. But I mentioned to you that maybe we could rename the variable, like instead of using n, maybe I could use x and then it would work. No, we saw it not work already, okay? So we know the spoiler alert, we know the outcome. It's not going to change anything. All that's going to happen, and it shows very well on the debugger, so we're going to jump back in the debugger real quick. If I do something like this, well, let me use max because it doesn't matter what the method do, right? And I'm going to use a, b, and I'm going to use if A lesser than B, then return B, otherwise return A. So what I did is I did what the slide was suggesting, but with a different piece of code, right? I said my main method has variable A and B. Now I'm going to use A and B in the max. Does it matter? Absolutely not. Let's compile this, make sure it's compiling. Let's run it. Actually, I don't want to run it. I want to run it with the debugger. So let me click this beetle icon here, and we are there inside of the main method. Okay, we have A and B that are not yet declared, so I'm going to step forward. There we go. A and B have been declared now, so they are here in the activation record for the main method. And then I step forward. I call the max method. Step forward too fast. Sorry, hold on. Let me rewind. We start from the get-go. There we go. A and B are here. Then I step into the call to the max method. There we go. This is my activation record for the max method. A and B are 4299, but look, there are two pairs of variable named A and B. One of them lives in the activation record for the call to the main method. One of them lives in the activation record for the call to the max method. So same thing, changing the name of the variable has no bearing whatsoever on affecting the variable across methods. Okay, and we have that because of the activation record. The fact that the activation record are isolated from one another gives us all of those properties of the programming language. All right. What does this program do? Well, it's kind of the same thing. Okay, it's kind of the same thing here, but it's kind of like the classical example. So I'm going to run through it real quick so that you got exposed to it. We want to write a swap method. And this kind of stuff actually is interesting because when I used to teach advanced Java for the MSIT track, I would get people that come from anywhere, like from USF, from other universities, from other countries, etc. And all of them were supposed to know actually how to program in Java. And what I gave them first day, like a master level class, first day of class, I give them a swap method. And I was trying to gauge, can you tell me actually why it's not working? And you would be surprised. Okay, you can go through many programming courses in Java without ever being told actually what's happening here and why you cannot actually have a method that's going to swap the content of two variables that are of a primitive data type. And when you don't know that, when you don't realize that, and you go into using objects, generally you start using objects the wrong way. So this is also what we start COP2513. So that anybody whom I didn't have a chance to bother with that in COP2512 is going to be on the same page than you. So here we have two variables in the main. We want to swap them. The swap method is really easy. There's a lot of println here to tell you what's happening, okay? The swap method is just swapping the content of the two parameters, but that's the key, right? We swap the two parameters, we don't swap the variable from the main. So if I do the stack diagram, entering the main method, here is what I get. Entering the swap method, here is what I get. Parameter n1 and 2 have been set to 2 and 1, which are the value inside variable num2 and num1. And then I execute the code inside the swap method. So temp is equal to n1. Here we are. Then n1 is equal to n2. There we are. And then n2 is equal to temp. So yep, I did my swap. I did my swap entirely in the activation record for that method. But I call to the method swap. And then all of this goes away. And the main has been left completely untouched. And then we complete that and we're done. So all of this stuff about activation record, they determine, visibility of method, visibility of variable, sorry. Visibility of variable means if I declare a variable in that part of the code, what are the part of the code where I can actually access it? Like read the content or change the content, okay? That's called the scope of a variable. And so far, what we have seen is, even before you talk about activation record and all that stuff, is that the scope of a local variable is defined inside a method. Well, it lives inside that method. So now you know exactly why. And what we have seen also is that we have to initialize them. And now you know exactly what's happening if you do not initialize them properly. The scope in Java and also in C and C++ and most modern programming language is a little bit more complicated than that. Even in JavaScript, they changed it. JavaScript 10 years ago had a concept of scope that was slightly different from what I'm going to explain here. The scope in Java is not just based on the method. is based on the curly braces. And we talked about that last lecture, right? If I open and close the curly brace, I got myself a block of code, right? We were talking about loops. So what happens if I declare a variable inside the body of a loop? It's usable only in the body of the loop, inside the curly brace of the body of the loop. So that's the idea of scope that I pre-introduced back then, okay? So that's how Java sees a scope, actually. That's how most modern languages do. That's how JavaScript sees a scope nowadays. 10 years ago, JavaScript was just saying, you know what, I don't care about block scope. So every time you declare a variable in a method, even if it's inside, like your loop or whatever, I'm not going to restrict access to that variable inside that particular block of code. I'm going to make it available to the entire method where it's declared. Okay, so in JavaScript, we use functions, but same idea. Okay, that created a little bit of a wonky programming language. Okay, and a lot of people kind of complain about that, which means that you could declare your variable anywhere in the code for your function, but then JavaScript would say, okay, let me move them behind the scene to the top of the function so that they all appear declared at the beginning of the function. Okay, so again, I'm just telling you that so that you know that as you learn more programming language, this is another thing that you need to really ask about. Like if you're like working in a company, they use a weird programming language, never heard of it, you have somebody mentoring you, this is the kind of stuff you want to talk with your mentor at lunch. Okay, how does a scope work in this programming language? So in Java and C and C++, we're lucky, it's block-based. It's very easy, it's very natural. Every time you open a curly brace, you get a block. If you declare stuff inside of there, it's going to be limited to that block. And we use block for the body of methods, for the body of loops, so that extends to all of this. We kind of already saw this in action. But then at some point I had a question and I kind of dodged the question. I answered I would say 80% of the question, but I didn't, really answer the whole question. The question was from one of the students in this morning session, if I remember correctly. And the question was like, okay, we were dealing with loops and I had a variable int I, inside of 4. And the question was like, so you mean that I can declare another int I in another block of code and it's going to be okay? And I said, yes, look, you have a block of code for the for loop here. I put another block of code for the next for loop here, and I can actually redeclare another variable named I, and it's okay. Well, there is a little caveat. There's a little asterisk to this rule, is that you can do that. You can declare a local variable with the same name multiple times in different blocks as long as they are non-nesting, okay? So what I mean by non-nesting is kind of like self-explanatory, right? Let's take an example. This would be a non-nesting, two non-nesting blocks. So I say I have variable x and y. What is the scope of x and y? This block of code starting here to here, okay? So x and y are usable inside the entire body of the method. What is the scope for I? Well, I use that wonky syntax that allows me to declare a variable here in the first segment of the for syntax. So that means that I is usable here in those 3 segments, and it's usable in the body of the loop for. As soon as I'm done with the loop, it's gone. I cannot access it anymore. So if I try to restart another block of code here, another loop, and I say I want a variable named I as well, no problem. At any point in time, there's only one I. That's the key. So this works without problem. This one, not so much. So this one, the difference is I still have x and y that are local variable for the method named my method. Their scope is the entire method. And then I create a block here for my for loop. And I say inside that for loop, inside the scope of that for loop, I want a variable named I. Sure, no problem, okay? And then inside the body of the for loop, I want a variable named x, a local variable named x that I declare so that that x exists only in this loop. Again, different language are going to do it differently. Some language are going to say, oh, you have an x somewhere in memory, but now you're like inside the loop and you want a private x that you can only modify inside the loop. Sure, I'll give you that. Some languages do that. In Java, this is going to lead to a compilation error because Java is going to say you are trying to get the variable named X inside that scope, but that scope is nested inside the scope of the method named myMethod, and that method has already a variable named X. So Java refuses to have multiple variables in nested scopes that are going to have the same name. Same thing here, okay? Except that here I declared the int X, I declared it inside the body of the loop. And here I declare the int I, using that special for syntax here, which gives the same result, right? I is accessible for the body of that for loop, but I already add I here. In both of those cases, Java is not going to let you get away with it. And we kind of introduced all that already when we did, the for loop. We had some example. We looked at example where we were exactly talking about this kind of stuff. Okay, so now we're kind of revisiting that, putting like the dotting the I, dashing the T's. Okay, making sure that it's actually grounded in justification that correspond to what happens under the hood. All right. So just so that you know the kind of compilation error message you're going to get. So in this case, I have a for loop. Well, actually, you know what? We talked about that. What's happening here? We talked about that last lecture. Where do I get this? Which one is it? Cannot find symbol TMP.
Because it's initialized inside the loop.
Yeah, it's initialized inside the loop. So where is it complaining? It's complaining there, right? So before the body of the loop. So that makes sense, right? I didn't declare TMP until here. Now, if I declare int n equals 0 here, why can I use it here? Just because that's a peculiarity of the syntax, right? Peculiarity of the syntax is if you declare a variable here, it's usable in that 3-segment syntax of the for plus the body of the loop. If you declare it here, it has scope only strictly in the body of the loop. So it doesn't even have scope between those fragments, okay? Again, little detail. When you learn a new programming language, you get bombarded by little arbitrary rules. Do that, don't do this. This is how you have to write it. You cannot write it like this. And then progressively, you have to dig further and figure out exactly why you have to abide by those rules, okay? I think this is the last topic we are going to cover. We're going to talk about overloading methods. Again, normally, if I did my job right, you guys have already at least a basic notion of what overloading methods are, except we didn't call it really overloading method. I mentioned it one time, the real name. But I showed you what happened, like, hey, I have this method square root, math.square root, right? And I can call it and pass an int, and it returns an int, for example. It's not true for math.square root, but let's go along with that. And if I pass a double, it returns a double, okay? That would be true with the math.absolute value, sorry about that. So the bottom line is we have some methods that we've used before where there are multiple versions of the method with the same name, okay? So how does that work? Well, when I call a method in Java, when I call the method, I'm going to look at all the arguments that I have, the number of arguments. So I'm going to look up the definition of the method system.out.println in this case, okay? I'm going to look at whether I have different versions. Then I'm going to look at all the versions. I'm going to filter out all the versions that have less or more than one argument. Then I'm going to look at the data type of this expression. Message, in this case, should be a string, okay? And I'm going to look at whatever is left, all the version of system.out.println, and I'm looking for one that takes a string as argument. Only one parameter which is declared of type string, okay? That's pretty much method matching. We are going to revisit that again in COP2512 because it's going to get a lot more complicated. But right now, it's relatively simple. You call a method, Java is going to look up for all the definition, try to find the one that matches the best the usage that you are making of the method here. And if, for example, I didn't have a println that takes a string defined somewhere, then I would take the argument that you gave me here, and I would look at it and I would say, can I do some implicit casting? Can I turn that value, whatever data type it is, into a string? Because if I can, well, println obviously wants a string. So I'm going to take whatever you give me and I'm going to upgrade it to a string, and then we're friends again. I can call the method. But if there is no implicit casting possible, then I'm screwed. Okay, meaning that I cannot actually make that method call work. So that's the stuff the compiler is constantly checking every time you call a method. And we can have some interesting cases. For example, here, let's say that we rewrite our own version of the max method. Okay, and this is how we want to use it. So public static void main, the max of 3 and 4 is, calls the method max, parameter 3 and 4, sorry, argument 3 and 4. These are int values. Whatever max return is what I display here, so it should return 4. And then system.out.println, the max of 3.0 and 5.4 is, and now my arguments are of data type double, same method name. Whatever it returns to me, I want to display on this line. And then the max of 3.0, 5.4, and 10.14 is, and now I have a max method that takes not 2, but 3 arguments, and those arguments are all of data type double. So I'm setting up an example here where I would have 3 different versions of the definition of the max method. All of them are going to be named max. Their signature, remember how we defined signature last lecture? The signature is the name of the method plus the list of arguments and their types. Well, the names are always max, but the signatures are different. Okay? All right, so this is acceptable in Java. You can't have totally this kind of stuff. Okay? How is it going to look like when we implement it? Public static int max num1 num2. Okay, if num1 greater than num2, return num1, else return num2. There's at least 3 or 4 ways we can write this by now, refactor it, okay, but you get the idea. We have been doing that already for a while, okay? So no complexity there. Public static double max takes a double num1, a double num2. Okay, so this is what's called overloading. If I had in my entire project, if I had only one version of max that takes 2 int parameters and returns an int value, that's what we've been doing since day one, no problem. This is just, here's a method, okay? But now I overload the name max by saying there's more than one version, and the compiler is going to check that, hey, this list of argument should be different than this list of argument. If not, if I was trying to say int num1, int num2, or int x, int y, the name of the argument doesn't matter. It's their data type that matters, right? This one takes 2 int. If the other one here takes 2 int as well, whatever you name them, it's not going to work. The signature is the same. So here it's working because signatures are different. I have a double num1, a double num2. What about here? So now this is my 3 argument version. So public static double max, it returns a double. It takes double num1, double num2, double num3. Does it clash with this one? No, because this one takes 2 int, this one takes 3 doubles. Does it clash with this one? No, because this one takes 2 doubles, this one takes 3 of them. So we're good. The method signature do not clash with one another. I am allowed to have in my class, in my Java file, 3 different implementation of the max method. And then, just to have a little bit of fun, fun asterisk, okay? Just to have a little bit of fun, I don't want to keep rewriting the same thing over and over. I did already if num1 greater than num2, return num1, return num2. I did it again here. I could have done something very similar here with just one more level of if else. Why did I try to replace this by calling the max of num3 with whatever the max of num1 and num2 is? Because that does the job, and it allows me to do the job without having to rewrite the if-else logic that computes the max of 2 numbers. I know the max of 2 numbers is trivial. It's not a big deal to rewrite the code logic, but I'm just showing you on a trivial example how to do things properly. When you guys are writing here 50 lines of code, like here, for example, 50 lines of code that are a nightmare, that took you 2 weeks to get working, right? And then some intern comes and cut and paste them here, and then things like, hey, I'm going to optimize them and start modifying stuff, etc. You're going to waste your time if you're not disciplined in the way that you write code, okay? Here, we don't want to duplicate the logic of the code. We want to reuse the code that we already wrote elsewhere. So if we want to do that, maybe we should do it here, though. Because right now, this and this is duplicated. The logic is the same, the logic of the algorithm in the method, right? So yeah, I can change that. I call max, the max that works on double, okay? But I was given 2 int. So I'm going to explicitly convert my int to a double. And by the way, I don't have to do that technically. I'm just putting it so that you see how it's working, right? But I could have an explicit, I could have an implicit typecasting here because going from int to double, Java can do automatically for me. I'm casting num1 to a double, casting num2 to a double, calling max. So when I call max, now Java is going to say, which max is it? Well, it's the one that takes 2 arguments. So that's definitely not that one. So it's that one or that one. What is the data type of argument? Double, double. Okay, you're calling this one. That process of identifying which version of the method is done every time you call a method in Java. So by converting the type to double here, I make sure that this is going to call this method. This version is going to call this version. And then this version here is going to return to me a double. I'm going to convert it to an int, return it, because I said I was going to return to an int. This is actually better code. It might look like I'm wasting my time or trying to show off or using like type conversion because, just because I can. But no, actually, this is better code. And yes, it's a trivial example, but the bottom line, the rule here is do not repeat yourself. Okay? That's called the dry principle in programming, DRY. Don't repeat yourself. And that's not actually repeating ourselves, it's reusing our code. That method in the middle, we can keep on going and make a version of max that has like 4, 5, 6 arguments. I'm going to be smart and I'm going to try to reuse what already exists to solve those new problems. Last example. What's happening here? I have method overloading. Okay, so that's still what we're talking about in this section of the slides. Okay, I have method overloading. The name of the method is max. Inside the main at the bottom, I call system.out.println max with arguments 1 and 2, data type int and int. Okay, so let's look at the definition of the method max. The first definition at the top says public static double max int num1 double num2. And then the code, yeah, it's still the same code to do the max. Okay, so let's disregard that for now. The second definition of the method max, public static double max, so it still returns a double, and then it takes as parameters double num1 and int num2. So I swap them around, right? Like here, the first version, the first argument is going to have to be an int, the second a double. Here, other way around. The first one is going to have to be a double, the second one an int. So these are the 2 versions that I have available to call. And then what I call in my main is max of 1 and 2. So let's call the top version version 1, the middle version, the bottom version version 2. Okay. Which version is actually executed when I do this code? When you got it, just show me a 1 like this, or show me a 2. Okay. Okay. Which one was it? I didn't see. Yeah, okay. Those of you who are kind of stuck right now, talk to me. Why are you stuck? What's the problem? What doesn't smell good about this code? Yeah? Mm-hmm. No, I don't want to change that. Okay. Yes, I could make a version of max that takes 2 double arguments, right? but I'm setting up the problem so we have one that takes an int and a double, and the other takes a double and then the int, right? And we're not going to change that, but yes, if I want it, I could have a third version, that's, for example, takes double and double. Yeah, it's perfectly allowed. But before we move to that, I want you guys to kind of like feel the pain for this example here, right? It's not actually trivial to decide between 1 and 2. That's why we use that example. It's actually not trivial for us to forecast which one Java is going to use. And the reason it's not trivial for us is because it's not even trivial for Java. So this is what Java is going to tell us. It's going to tell us there is an error, compilation error, okay? And it's going to tell us the reference to max is ambiguous. Well, that's interesting. So when I call max here, like in system.out.println max, there's a hat, tells me like right there, Java says, yeah, I don't know which one you're calling. So what's different? It's still method overloading. We've done method overloading for the last, I don't know, like 10 minutes, 15 minutes. What's different here? Yeah. Yeah?
So like to match one on the 50, match no more on the no two.
No. The way that we have them written is actually okay. We don't have to change that, okay? Well, let me rephrase that. Yes, the way that we have written those methods is what caused the error. So you're right with respect to that, okay? But what I mean is that we are not trying to fix it yet. We're trying to just explain why there is ambiguity for Java. So why can't I just convert 1 and 2? We know how to do typecasting, right? Java does implicit typecasting. So 1 and 2 are int. Okay, so the first one, let's take the first version. My first argument is 1. Data type int. My first parameter is num1, data type int. No problem. The second argument is 2, data type int. The second parameter is num2, data type double. So I didn't have a problem going from int to int. Do I have a problem going from int to double? No. That's implicit typecasting. So it's a double-edged sword, okay? The bad thing with programming is that every time we learn something new, you cannot let it go. You have to keep it in mind for like the rest of the course, the next course, the next course, the next course, okay? It's kind of like calculus. It makes the topic a little harder to teach. The good news about programming is that almost everything that we look at is going to be revisited. Like right now, we're talking about a different topic. We're talking about method, activation record. We're talking about overloading. And guess what our problem is? It's typecasting, okay? So I can take a 2 and upgrade it to 2.0. That's called implicit typecasting. It works because int is a small data type that has a small range. Double has a wider range, so you can upgrade an int to a double, not the other way around, okay? So Java could actually take 2, pass it as 2.0, and then here we go, I have a double. So, but it's telling me that it doesn't know what to do. Why? Why doesn't it just do what I suggested here? What's going on with version 2? Would version 2 be better? See what I'm saying now? So what's the deal with version 2? Okay, I call max with 1 and 2, 2 int. 2 is an int. Version 2 of the method takes an int as second parameter. Int to int. Check. The first one is an int. This one wants a double. Well, I could just upgrade my 1 to 1.0. Ah, this is it. This is where it breaks apart. It's like if you look at the 2 version, number 1, none of the version is a perfect match. Very important. If one of them was a perfect match between the call and the version of the method that I'm going to use, then I would not be talking about this stuff here. But none of them is a perfect match. This is int int. This is int double double int. So no perfect match. Second thing, Can I actually fix things? Can I use what I know how to do as a Java runtime environment, which is, implicit typecasting? Can I fix those arguments by upgrading one of them or maybe both of them and make it so that I can call one of the method? I can do it for the version 1, but I can do it for version 2. And there is absolutely no indication whatsoever in the code from the programmer telling me which version she or he will prefer. So this is why the compiler say it's ambiguous. I'm not touching that with a 10-foot pole. So that happens sometimes. Okay, it's relatively rare. We don't mess around hard enough with overloading, at least in this class. That is going to really be something that you have to worry a lot about. But yes, COP2513, we are going to do again overloading. We're going to do again a lot of the stuff that we did in this class, so don't forget it during summer. By the way, that's a problem. Okay, those of you who are taking the class with me this semester, hopefully, all of you are going to pass and move on to the next class. During summer, kind of refresh your brain a little bit about Java, because otherwise, sometimes I have some students that come back in fall and they forgot like everything about typecasting and stuff like that, and it makes your life a little harder. Okay, so just keep that in mind. But yeah, this is one of those topics. You can mark it with a red mark, in your slide deck. We are going to revisit that. Last of the slide, I'm going to go fast because it's just an example, and we're going to wrap up with that. So that means that we should be, we did wrap up actually module 8 today, so pretty good. We have an example here that's going, so there's a little bit of blah blah about benefit of method, etc. We already covered all that, okay? This example is important because it's going to show us a different way to organize our code. Until now, every one of the project that we worked on, it's not really a project, but every program that we wrote was contained in a single Java file. And I kind of stretched that, for as long as I could, because I didn't want to introduce more complication. But the truth is that when you write an app in Java, that app can have like 50,000 .java files. This is not a problem at all. And then if you want to organize them neatly, then we need to talk about packages. So forget about packages. We're not yet there. Okay, but let's talk about what if I have multiple .java files? What if, for example, I'm working with like 5 of you, and each of us is working on one separate Java file. That's kind of like the ideal case in a team. We're each working on our own separate Java file, but I'm taking care of the main, and you guys are going to take care of some other method that I need to be able to use. Well, we haven't learned to split code over several files, but it's easy. It's very easy, especially with JGraph, and the way that we keep all of our Java files in the same folder, that's going to be super easy. So let's take an example here. Public class, my project. It has a main method. Remember, every application needs one main method. So this is where it is for my whole application. And I want to call a method called hello, but it's not defined in this class. I'm going to define it in another class called my library. So how do we do system.add println or math.sqrt or stuff like that? We put the name of the method dot the name of the class, my library, dot the name of the method you're calling, parentheses to show that it's a method call. So where am I going to define this method? Another file, my library.java, my project.java, and my library.java are in the same folder. We just use a basic, package, flat package, layout in Java. So I have a separate Java file. I say public class my library, public static void hello. Here's my hello method that just says, what's your name, and then say hello, your name. And as long as those two things are in the same folder, I can compile this. Then I can compile this, and then I can run this one, the top one. But I cannot run the bottom one. You see why? Bottom one doesn't have a main. So we are learning to write classes that do not have a main. Those classes are not meant to be executed directly. They are meant to provide methods that people, other programmer, yourself, can call from another Java file. Okay, so this is our first step toward object-oriented organization and stuff like that. We are writing this time for this application, for this project, we are writing two classes, my project, my library. My project is where the main is. This is where execution will start. Only one main across all of the Java file for that project. And my library just provides a public static method named hello. So the advantage of that, besides the fact that I can say, oh, I'm going to work on the main. I'm going to do all the work for that one line of code, lucky me. And then I'm going to ask somebody else, you do the work for my library.hello, okay? So besides the fact that I can easily split the work like that and organize my application as it gets bigger and bigger in a way that makes it easy to find the code that relates to, some specific features and so on and so forth. I'm also able here to take that my library.java, and then let's say that I'm assigned to project one every morning of my work week. In the afternoon, I work with another team, another project, but we need also a hello method. Yeah, I know I'm stretching it with the hello stuff. Huh? But bottom line is I can take this Java file, I can pass it to my second team of co-programmers. I can tell them, hey, I wrote that already for that other project that I do work on during the morning. We can reuse it as is in our application. All we have to do is take my library.java, put it in the folder where all the files are for that other project. And now, from every other Java file in that project, I can call my library.hello, and I'm going to call that method. First step toward code reusability, code action. Okay. Application get bigger, application get huge, but we have tools to control the complexity. All right, that's it. That's it for module 8. The next case study, I'm just going to leave it there so that you can take a look, but it's going to be pretty much a code example that is on the reading assignment as well. Thank you for your attention, and if you have questions, I'm not running anywhere.